Hello everyone, in this video we're going to talk about how to find zeros of a function. So this term zeros, it's very similar to the solution to an equation or the root of the polynomial, and that's kind of what we're going to take a look at in this video. So when we're talking about polynomial functions, so a quadratic function or a cubic function, anything along those lines, we can find the x-intercepts of the function and we can graph those. And so the x-intercepts, if you think about that coordinate, the x-intercept has a y value of 0. So that's where this word 0 comes into play. The zeros of the function are essentially what is x when y is 0. Okay, so we see that for any factor x minus n of a polynomial, n is a 0 of the function defined by the polynomial. So essentially what we're going to do is we would take x minus the number, we would set it equal to 0, and we can use the zero product property if we have multiple factors and find what our zeros of the function are, which essentially they are the x-intercepts of the graph. So let's look at a couple examples here. So the first one, nice and easy, it's already in factored form for us. So we have x minus 4, we can set it equal to 0. Basically, let's start a little bit back here. Really what we're trying to do is we're trying to set this equal to 0. So we're going to say 0 equals x minus 4 times x plus 6. And so now we have a product that's equal to 0. That's the zero product property, which states x minus 4 either has to be 0 or x plus 6 has to be equal to 0. And that's why we can go ahead and set these equal to 0. So here we get x equals 4, and here we get x equals negative 6. So our zeros of the function are 4 and negative 6. Okay. All right, now on the next one, it's not in factored form. So we need to factor it as long as it's factorable, and this one is. So the first thing we want to do is always look for that GCF. And we have that because our values are, our a, b, and c value are even numbers. And so we can factor out this 2. So if I do that, we get x squared minus 4x and minus 12. Now we can factor what's inside the parentheses. It's just a trinomial, and a is 1. So we just need to find what two numbers add to b and multiply to c. So what two numbers add to negative 4 and multiply to negative 12? Well, we're multiplying to a negative, so we know one of our values needs to be positive and one needs to be negative. So we can say 0 equals, we're just going to keep that 2 out there for right now, and I'm going to say x minus something and x plus something. Okay, so let's think what numbers multiply to negative 12. Well, negative 1 and 12, that doesn't add to negative 4. Negative 2 and 6, ooh, those are numbers that could add to negative 4. But we're adding to a negative, so we want our larger number to be negative. So let's say x minus 6 and x plus 2. So if we multiply those together, negative 6 times 2 is negative 12. Negative 6 plus 2 would be negative 4. So now we can set these equal to 0. So I'm going to say, let me delete this. So we're going to say x minus 6 equals 0 and x plus 2 equals 0. So here we get x equals 6 and here we get x equals negative 2. So our zeros here are 6 and negative 2. Okay, so this 2 right here, essentially we can just forget about it or leave it off for right now when we're just finding the zeros of the function. Okay, we did a previous video on how to graph an intercept form. So that value helps us with intercept form. It tells us if our parabola is opening up or down. But for right now, for finding the zeros, we can kind of just ignore it. All right, and for the last one, h of x equals x minus 2 times x squared minus 25. So we're going to set this equal to 0, and our first factor, x minus 2, is completely factored. So it is going to stay the same. But now x squared minus 25 is actually the difference of squares, or the difference of two squares, because x is squared and 25 is a perfect square. So we could write that as 5 squared. So that factors as x plus 5 times x minus 5. And now we have 3 factors here. This would actually be a cubic function. And now we can say, or now we can set all of those equal to 0. So we can say x minus 2 equals 0, x plus 5 equals 0, and x minus 5 equals 0. So we get x equals 2, x equals negative 5, and x equals positive 5. So we could say our factors are negative 5, 2, and 5. And those would be the zeros of the function.